So what we want to talk about here is this is the distance before the function repeats its shape. Now, in the parenthesis, I'm going to put a symbol. I'm going to use a symbol to represent period. We're going to tau, isn't it? Okay. It's not a T. It's got a what? Sort of leg on the top.
Theta, maybe?
Tau.
It's not like Greek.
Huh?
Is that a Greek symbol?
Yeah, it is.
So Greek
You know,
symbol
mathematicians
vowels.
like to use a lot of different letters. This will work. So now here's what we want to do. I know, there's not one of those symbols in your equation. I get that.
Okay.
So let's play around with this thing for just a minute. We set on our screen right now with just the sine of x. How many repeats do we get? So let's see what happens if I make the sine. I'm going to put something in here. Now, before you hit graph, think about what you think it's going to do first, and then look at the picture. Let's see what happens. Think about what it's going to do if you put a 2x in there instead of just an x. Think about it, and then see if you're right based on what the calculator does. Now make sure everybody gets to see it too.
That didn't do anything.
Yeah.
Okay, hold on. I'll show you.
So what did this do? What happened?
Why is many repeat?
So the distance that it takes to repeat shrunk, right?
Yeah.
Interesting. So how many repeats are on the screen for this curve now? 4 across the screen. All right. I think we need a little bit more information. Somehow this number here is causing it to do something different. It turns out there's a little equation that we need. Tau is equal to, period is equal to 2 pi divided by that constant b that was in our equation. B up there. Would it make sense if I take this 2, put it right here, 2 pi divided by 2, is that pi units? So every repeat occurs every pi units, and we've got how much across our screen? 4 pi. So that's why I get 4 repeats. Does that make sense? All right. Yes, ma'am.
So what does that do for us? That tells us how many repeats?
This is telling me the distance it needs before it repeats. In other words, for this equation, every pi units, I get a repeat. That's called the period. For this equation, every 2 pi units, I get a repeat. What I want you to do now is across that whole screen that's 4 pi units wide, I want only 1 repeat. Only 1 curve. The whole thing, but I want it once. Can you write the equation so you get it 1 time? If you don't have a calculator, write down what you think it might be. If you have a calculator, try it and see. Everybody, please check and make sure you see it and you see the equation. What do we think?
Want to tell you?
Yeah, I want you to tell me.
I got sine of 0.25.
You got 0.25. Okay. Does that mean it goes up and down and then back up across your screen?
Almost at it.
No, it just goes, it goes up. It just goes, does like this. It doesn't do the...
It doesn't. You don't have the backups on either side. Go back down.
It has to go
It's a little too wide for me.
up, down.
No, technically you were wrong too.
Let's try that one.
You were
I have
wrong.
my side.
I did that.
Down or down?
Good.
It didn't...
Do you see the difference in how you get a little bit of an up and then a little bit of an up on the bottom? Change it just slightly.
Could you just not say it?
All right. Hey guys, suppose that I asked you to do something not not quite as nice as 1 repeat in 4 pi. Maybe it was something different. How would we go about mathematically to find the number that I'd have to put in here to actually get what I wanted to get? What could I do?
If you
Okay, now what did I tell you I wanted? In that 4 pi, I wanted what?
One.
So didn't I tell you the period number?
Yeah.
So I might go in here and say 4 pi equals, so 2 pi over b? So mathematically, would I then want to solve that little equation to find the b number? So how to do that?
Okay.
divide 4 pi by 2 pi, which is equal to 2.
How about we do 4 pi b equals 2 pi, and we divide by 4 pi? That work?
Yeah.
That's one way to do it. There's your 1/2, or your 0.5. Questions about that? Okay, so now we have looked at already that we can take and expand the amplitude, that we can take and shrink the distance needed to get repeats, or expand the distance needed to get repeats. What else can we do to this thing? Did you slide it? Would that work? Yes, ma'am. Yes, I can.
Is that a...
That's a 2.
That's a 2?
That's a 2.
Looks like an X.
No wonder I get those funny looks. How about that? That nicer to you? And you think me writing on notebook paper would be nice and neat. It's not. Alright, we ready? So now what we want to think about is sliding it left or right. Well, that has a name also.
It's like everything in math has a name.
Yes. Phase shift. This is the slide left or right. Any guesses as to what one of my 3 letters, 4 letters? That's the one.
Wait, so tau equals b? Sorry. Or
No,
like,
it does not equal b.
It equals 2 pi.
Over b, yes. So phase shift is slide left or right. Yes, ma'am.
Is the center line always going to be 0?
No. But d, as a constant, will let me slide it up or slide it down, depending on what that number is. Okay? But no, it's not always at x equals 0, or y equals 0. Okay. So let's consider this. Remember, we still should have in our calculators this equation, y equals the sine of x. Correct? So beneath that somewhere, let's put in y equals the sine, let's see here. Let's try x, the other one, plus pi. X plus pi. Think about what you think it might do. And if you're not even sure at all, just graph and see what it does. So what did it do?
Shift 1 pi.
Shift over pi units, didn't it? Which way did it shift it, left or right? No, it's not either. There's a particular direction it went.
Minus and negative.
Yes. Guys, you remember when we did horizontal shifts in our algebra class? We would always think about this as y equals the sine. And we wanted the distance between that and the number that moves. So that means I'm moving which direction? Left pi units, because it's negative, so we go pi units left. Yes?
So is it
You
just
believe
like
that? Yep. If you got both these graphed together, basically you're going to have one shape that goes up like this, the other one goes down and then up Okay, kind of makes it almost look like a double helix without the connections of the DNA string. You turn it sideways.
Biology.
So if we do minus pi, we do...
Multicurricular, right?
Yeah.
Oh, no.
502. I know what's going down with the
So x plus 5 is x minus negative 5.
Right, but what I do minus pi, so right.
Let's find out. Let's rewrite it like that. Let's do x minus pi and see if it looks any different.
Yeah, no, they look the same.
Did it look the same?
Yeah.
Why might it look the same even though we moved both directions?
Because that's
Again, it's because that's half a period movement. So it doesn't matter if you go left or right with a half a period movement, you're always going to get the same picture because of the periodic nature of the full period. One of those nice.
But did it go right?
Yeah, it did.
Okay.
It did. And to prove it, let's do this one. Leave your sine of x in there. Let's do y equals the sine of x plus pi over 2. Let's move this a quarter of the period. And let's move that left. It should move left a quarter of a period. So we got?